Alright, so then this last video on quadratic formula examples, I'm doing a more difficult one. I had two videos before this. If you're struggling with this one, go back and watch the medium one and then the easy one. Probably easy, then medium, then difficult, right? Alright, so in this problem, we've got x squared plus 2x plus 4 equals 0. And if you were to look at the graph of this, you would notice that this graph does not cross the x-axis. So our final answer is going to have roots or zeros that are imaginary. Right? So we're going to be looking for our complex roots. All right? So I'm going to use the quadratic formula. The opposite of b, so negative 2 plus or minus the square root of b squared minus 4ac. Very similar to the medium example, except I changed this negative 4 to a positive 4. So almost everything's the same except for that, and that makes a big difference. And the reason it makes a big difference is because we end up with, underneath the square root, a negative number. So let's see why. 2 squared is 4 minus 4 times 1 times 4. 4 times 1 times 4 is 4 times 1, which is 4, times 4 again, which is 16. So we end up with 4 minus 16. 4 minus 16 is negative 12. So right off the bat, you're like, uh-oh. We've got a negative under the square root, which is going to give us an imaginary number. Our answer is not going to be a real number, it's going to be an imaginary number, right? Because of the negative under the square root. Okay? So let's just keep going. And actually, maybe I should work over this way. Let's deal with this square root of the negative number. Let's deal with the fact that it's the square root of 12, and then to deal with the fact that it's a negative. So I'm going to break up the square root of negative 12 into the square root of negative 4 times the square root of 3. Why? Because 4 is a perfect square, and so I want factors of 12 that include perfect squares. So the square root of 4 is 2. Now it's the negative, so what that really means is we have the square root of negative 1 times the square root of 4 times the square root of 3. Why did I do that? Because I wanted to show you that square root of negative 1 is just I. Alright, and so this is I times 2 times the square root of 3. And typically the way we would write that is 2i, then root 3. So when we deal with this part right there, we're going to end up with negative 2 plus or minus 2i root 3. That's three things. 2i root 3. And again, that came from the square root of negative 4 is just 2i. Square root of 4 is 2. And then that negative part is the square root of negative 1. That's just the imaginary number I. All right, so I had to really break that down. Okay, first look for whatever's under the square root and break it down into factors that include the biggest perfect square you can find. If there was a bigger one than 4, then I would use that. Okay? Because sometimes you don't want to end up with a square root where there's factors inside here that include a perfect square. So find the biggest one. All of that's over 2. All right, let's keep going. And we're almost done. So then, again, the thing here and here can both be divided by 2. So I'll do this in a bit of a shortcut. It's really negative 1 plus or minus I root 3 would be the way you could write it. Or you could write it like this. That would be one of them. That would be the other. And that's it. Those are your two roots. Again, they don't cross the x-axis. They're imaginary roots. Because this entire graph, if you looked at it, it lies above the x-axis, and you can verify that if you want. All right, so that's the more complicated example, and you'll need that when you study more polynomials.